Hey all, welcome back to my channel Higher Ready. In today's video, we are going to see something that's very much important. How important is this? You'll get to know how important is this by just looking into this video and watching it till the end. Because this is something that you should have a clarity before getting into the industry. So as a beginner, most of the people will have confusions where to start if they get a project after getting into the industry. Now working with basic projects is going to be quite easier. But after getting into the industry, what will you do? How should I start my project? Which is something that I should do basically. This is the common confusion that everyone is facing. So if you have this clarity right now, after getting into the industry, it is going to be much easier than you think. We have seen how to clean the data, how to create visualizations. Now it's time to get stronger with the foundation. In the previous video, we have already seen regression, classification, and clustering difference. So about those algorithms, you are going to see how to work with them in a detailed way. Now, before working with those algorithms, you should have a clarity on where should I start with any project. So model building, data cleaning and data reprocessing, everything is one of the steps. So in this video, we are going to clearly see the steps. So what is the step-by-step process that I'll be following for completing my project and working with them? That is what we are going to see in this video clearly and quickly. But one thing that I want you to do is take notes. Pause this video and take notes. That is very much important. The first step that you have to do is you might get into any data domain. Specifically, if you are working in ML, data science, or AI based projects, the first and important step is problem definition. The client is just going to give you the data and they are going to tell you the story that happened in the past. They are not going to provide you with any problem statements. Have you heard of this? If you want to solve a problem in maths, you just need to read out that question more than once. If you clearly understood the question, 50% of the problem is solved. And if you apply the rest of the formulas, the problem is solved. That's all. In data science and AI, it is more important to frame a problem definition first. How will you do that? You might get table data, you might get any data. So if you are getting a table data, in that scenario, if you want to understand the meaning of every single columns, how will you understand them? Do you think you can understand everything just by looking into the data? That is impossible. So if you want to have that knowledge, the first step that you have to do is research. After getting the data in hand, you should not directly get into the step of cleaning my data or asking my doubts to my senior employees. The first step is you go to online and do a research. Look into all the recently published research papers, what kind of solution they are given. So you will clearly understand the domain and you can clearly now create a problem definition. If you have the domain knowledge and the business knowledge, you can clearly now create a problem definition. So the first step is about understanding the domain and creating a proper problem statement. Then what is the second step then? It is about data collection. In most of the MNCs, there is a separate role called data engineers. Their work is collecting the data from various resources and providing to AI engineers, ML engineers, or data scientists. So, here is this simple what they are doing? No, it is such a complicated work. Data engineers, most of them are working around maximum of 13 hours a day. Based on the recent research, they found that. Why? Is that a tedious process? Exactly it is. It may sound like they're just collecting and giving the data. No, it's not that easy. That data, that business data might be stored in various resources. So it might be into internal database. I mean, their applications or something that they are using for their business. So they might need some public data sets that need to be used for projects. It might be inside the APIs. They need to do web scraping. So in such scenario, they might even store it in cloud resources. The work of data engineers is to create a pipeline of collecting the data and giving it to the AI engineers or data scientists in the team. So they are creating a pipeline not just for taking the data and putting it into the place where they are going to work. So in case if they are using any other cloud platforms, they need to do the process of creating a pipeline from cloud to cloud or from cloud to coding environment. So this process is quite a tedious process. Specifically, it is time consuming process. Most of the time they might miss the data. Sometimes various clouds will be used here, right? So they need to learn so many techniques. So it is one of the high paying data careers and on demand careers in 2026, data engineers. So the second step is data collection. We'll be doing it from various sources. The process of web scraping alone, this could be quite new for you, UPI, say APIs and web scraping. So Kaggle dataset is generally a practice dataset. So for some references and all, you can take that. API is generally for every website, for every application, there's a key that's generally used. So just by using it, you can take the data. And web scraping is about, based on the topic that you are searching for, or data that you are searching for, it will collect all the information available in the internet. So the data that you're going to get out of it is going to be messy. And you will be using this technique only if the data is not there. No data is available. Or just for doing further analysis or cross checking. So this web scraping data could not be the main purpose. The third step is data cleaning. So in this process of data cleaning, I've told in so many videos, 70% of project time will be invested in data cleaning because of the reason the data that we are going to get is a big data. It is really such a space consuming data. It is going to be a huge one. We can't even imagine how big it is. So in such scenario, cleaning it is not going to be a one line or two line of coding. It needs thousands and thousands of line of coding and many evaluations. Only then we can feed that data, cleaned data to our machine learning model. If we didn't provide a data that is clean to our machine learning model, it will not learn and understand it properly. So here in the step of data cleaning, you will be removing null values. What is null value first of all? It is the missing values in my table data set. So you can remove null values or you can treat them with statistical values like mean, median or mode. If you have any null values, you can replace them with mean, median or mode. We do have so many ways like interpolation for treating that null values, replacing them with another values that makes sense. So in this step, we do have the step of removing and handling duplicates. Duplicates in the sense exact same row or exact same column is repeated more than once. So those duplicates need to be removed. So the machine learning model will learn properly. So in this step, we'll be doing these two things as a major step, major process. The fourth step is exploratory data analysis. So this is where you will be spending most of your time in understanding your data. Before building a machine learning model, before testing it and delivering it to the client, what you have to do, you need to understand what is going on inside the data, right? How will you take information out of it then? If you didn't understand it, is it possible? No, right? So what you have to do is, you need to understand that data. So for the basic level of understanding, you can apply some statistical concepts like finding mean, median and mode value of a numerical column, or plotting and seeing the counts of any categorical columns, creating visualizations. So in this process, you will be understanding the data. It's you who need to understand the data. So that is why we have this step of exploratory data analysis. Fifth step is feature engineering. First, what is a feature? In my columns, in the table, if I have the table data, if I have to predict something, one column that need to be predicted, that column is called as target column. Other columns are called as features, and the final column that I'm going to predict is target. So the column that I'm going to use for predicting that target is called as features. In technical words, you should always use the word features instead of telling this column, that column. So feature engineering is all about finding out the right features to keep and putting out or throwing away the unwanted features or creating new features using the existing features. So in my data set, if I have so many features, around 10 features, I want to find if any feature is necessary for my project or not. I want to figure out, shall I delete any features? I want to figure out using the existing feature, shall I create any other new feature? So this is something I need to do a research and find it out. How you can do this with the domain knowledge that you're going to get when you are creating a problem statement. The first step that you took clearly, if you took that with dedication, this process is going to get easier for you, the feature engineering step. So here you will be doing that encoding process and all. Encoding in the sense if you have categorical values. What is it? If I have values like 4 types of laws, my machine learning model cannot understand it easily. If I convert them into numbers, like 4 different types of laws I do have, first floor is converted into 0, second floor type is converted into 1, third type is into 2, fourth type into 3. So my machine learning model can understand numbers easily. Do you know what? In our computer, if I'm giving it as text, it is generally getting converted into bits, which is zeros and ones. That is how my computer brain is understanding the data that we are giving. As similar to that, in machine learning models, if I convert my categorical data alphabet into number and if I give them, they can easily understand it. So the encoding will happen here. So it is all about the features, treating every columns as per the importance. The sixth step is model building. So in the previous video, we have seen regression, classification, and clustering, right? As similar to that, we do have so many models, deep learning, neural networks. We do have so many advanced algorithms. Based on my data set, based on what research I did, you should decide the right machine learning model. It is not always going to be the one right model. You are going to apply the suitable models and then you will figure out the right model. How will you figure out if I am choosing the right model? That is why we have the next step of model evaluation. So for every model that you are applying, you have some evaluation metrics. It might be accuracy, it might be R square value or anything. So that particular measurement is used for measuring the accuracy of my model. It is like getting marks for your examinations that you wrote. So this is the marks, accuracy value or R square value. So in the model evaluation step, based on the value that I'm getting from the evaluation metrics, I will tell if this model is suitable or not. If it is not as per my expectation, you can change the model. So which model is giving more accuracy? Based on that, you can decide this is the right model. So this is about model evaluation. Then what is the final step? Model deployment. This is the ultimate goal of our project. Our client has given us data, right? If I'm doing all this step and final result, what I'm doing? I'm going to give them as a website or an application, or I'm going to deploy something into a cloud and I'm going to give them that this is something that you can use. Your customers could use. This is what I'm going to do it. So that is why I have given here making the trained model available for real world use. So the main goal is here about allowing all the customers or your end users or systems to make predictions in real time. So here we are going to finally deploy the model and they are going to access it. It might be the final dashboard where they can always upload data and get insights. It might be an application, it might be a website. So deployment is about finally creating an active model that they could use for their business and providing them. So that is how the final step of model deployment works. So for this video, specifically for this video, I'm going to give you the description as a short notes. Okay. If you want to take screenshots right now, you can take it. So if my video is disturbing you, what I can do is I can make it very small so it will not be visible or it will not be hiding anything. So if you want to take screenshots, you can just take it. So this is the seventh step of model evaluation. Sixth step is model building. Fifth step, feature engineering. Fourth step is exploratory data analysis. Third step is data cleaning. Second step is data collection. And the first step is problem definition that you are going to create based on your domain knowledge that you researched and got. So, bye for now. We'll meet you in next amazing video.